Welcome to everybody. How are you, my boys and girls? We are interested in IIT JEE preliminary level or class 12 standard physics. The chapter is going to be solved is known as physical optics. My channel name is Bidyut Flow. You may subscribe as you like it. So let us go to the board. The wavelengths are of light rays are lambda A and lambda M in air and in another medium respectively. If the angle of polarization is theta, then the relation among the lambda A, lambda M and theta is given. One thing to be said, একটা কথা বলার আছে, এই ভৌত আলোক বিজ্ঞান বা ফিজিক্যাল অপটিক্স এখানে যেখানে যেখানে প্রয়োজন আছে এগুলো অ্যানালিসিস করার, বিশ্লেষণ করার, সেখানে সেখানে একটু একটু করে বিশ্লেষণ করে দেওয়া হবে ফর দ্য benefit of students. Although these are of 1 marks and these are of 1 minute duration or 2 minute duration in the exam hall, পরীক্ষাগারে এগুলো 1 নম্বর করে আছে এবং 1, 2, 3 নম্বর করে সময় পাওয়া যাবে বড় জোর। এখানে আমরা যেখানে যেটুকু প্রয়োজন আছে বিশ্লেষণ করার, because the studies are going to the best of my knowledge and belief in the lucid manner. We know for polarization mu equals to Ni. Suppose this is angle of I, here it is polarized light, here it is reflected light. When the angle will, you know it. I know I am not going to the explanation. I shall go to that fact where it will bring you some trouble. So mu equals to Ni. Here mu obtained from this wave length case, mu equals to lambda A this divided by lambda M, because lambda A is greater than lambda M. We know lambda A in air is greater than lambda M, because in other words we can write mu as mu equals to C upon C dash, where C is the velocity of light in vacuum and C dash is the velocity of light ray in the medium. Here this is n lambda and here this is n lambda dash, where n is the frequency which is constant. We know, so lambda upon lambda dash, this idea goes here. Lambda for the air medium or vacuum medium. In case of light, we take air and vacuum as same, and lambda is the wavelength at the medium. So lambda m. So we can write tan I, tan theta, where this angle is theta given. So this is tan theta. So this is theta. So we can write tan theta equals to lambda A upon lambda M, from which we can write lambda M equals to lambda A upon tan theta equals to lambda A cot theta. So answer D. This problem is based on Young's double slit experiment. In a double slit experiment, a light of wavelength lambda is used. A monochromatic light of wavelength lambda is used. A glass plate of thickness T and refractive index mu is kept in the path of one of the interfering beams. So let us go to the practical. What is the practical case? Suppose this is number 1 slit, this is number 2 slit. Raise so this is the, suppose this is this point is P. So there is a this is a general picture for Young's double slit. Mind it, this is a general picture for Young's double slit experiment, where the path reference is, suppose this is A and this is B. There is a path reference which is equals to BP minus AP. Taking perpendicular, we can get this is a BP minus AP, which is the path reference. This is the path reference. And here there is a this plate is inserted into the one interfering beam. One is here, one is, this is a coherent sources of light A and B, because there is a lens and rays coming from this to this in this way to get these rays. So these two are coherent sources of light. And so we get here as a path reference as mu minus 1 to T equals to D, here is a D, dx upon capital D. Here is x, here we know it. So from this we get, there is this, in the first dark fringe formed at the center of the screen. So at the center of the intensity equals to twice I0 into 1 plus cos phi, where phi is the phase angle. Phi is the phase angle. Suppose here is a phi, where is angle is phase angle. So for first dark fringe, this is I equals to, we know, for dark fringe intensity equals to 0. So we can write cos phi equals to minus 1 equals to cos of pi, means phi equals to pi. And phi equals to, we know, twice pi by lambda into path difference into path difference. twice pi by lambda into path difference. So this is get with as twice pi by lambda into d into mu minus 1 to this divided by small d equals to pi. From this implies the value of mu implies mu equals to pi pi cutting out mu minus 1t equals to lambda d. Mu minus 1t equals to lambda d upon twice d, and mu equals to 1 plus lambda d upon twice t d. Mu equals to 1 plus lambda d upon twice t. So d, so C is the answer. Problem: the wavelengths of two spectral lines D1 and D2 of sodium light are 5890 angstrom and 5896 angstrom respectively. A plane wave of sodium light is incident on a slit of width 2 micrometer. A screen is located at a distance of 2 meter from the slit. The spacing between the first secondary maximum of two sodium lines are measured on the screen is this. So this is the problem of single slit experiment. So suppose going to the board. Suppose this is single slit and the rays coming here into this direction. So for D1 line we can write suppose this is a at distance capital D, this is a screen S, and spacing and this angle, suppose this angle is theta, so this angle also is theta. And now this is a point P which is at a distance from center x1, suppose this is x1. Now taking a perpendicular from this, we get this is the path difference between this line and this line, the two end lines of the slit. We get this is perpendicular, so this is perpendicular to this and this is perpendicular to this, and the angle between these two lines is theta, so angle between these two lines also will be theta. No question, no doubt question. Here is a angle theta, so angle between this length and perpendicular to this length, this will also be theta. So here is the question here theta. So and this is a length, this is of a width given. So we can write this length as the path reference, which is equals to this is theta. So the so path reference equals to a sine theta. So path difference equals to, now from the figure we can write sine theta equals to x upon d. You can say, you can question, you can ask to us, you can ask as x1 upon hypotenuse. So with the sine theta, but here is the case, the distance between this screen and slit is 2 meter, very, very long, and the wavelength, whereas the slit distance, slit width are too much shorter than that of this capital D. So this length and this length can be taken by approximation for physical optics. So sin theta x by d, so we can write A into x1 upon d equals to n plus half into lambda 1 for d1, because n equals to 1 for the first secondary minimum. So we can write A x1 by d equals to 3 2 lambda 1. একই ভঙ্গিমাতে A x2 upon d equals to 3 2 lambda 2. So this one 1, this is 2. Subtracting 1 from 2, we get 2 minus 1 implies x2 minus x1 equals to d by a into 3 2 into lambda 2 minus lambda 1. So x2 minus x1 equals to d given as 2 meter, a given as 2 micrometer equals 2 into 10 to the power minus 6 meter into 3 2 into lambda 2 minus lambda 1 equals to 5896 minus 5896 angstrom into 10 to the power minus 10 meter. Because we know 1 angstrom equals to 10 to the power minus 8 centimeter, and that centimeter equals to 10 to the power minus 2 meter. So 10 to the power minus 10 meter. So after all, we can write 9 into 10 to the power minus 4 meters. So answer A. Two polaroids are placed in the path of unpolarized beam of intensity I0 such that no light is emitted from the second polaroid. If a third polaroid whose polarization axis makes an angle theta with the polarization axis of first polaroid is placed between these polaroids, then the intensity of light emerging from the last polaroid will be this. So this case is of two polaroids and one unpolarized light beam. When unpolarized light beam, I'm explaining word by word. আমি শব্দ থেকে শব্দতে আমি বিশ্লেষণে যাচ্ছি। When a unpolarized light, বাংলায় বলে অসমবর্তিত রশ্মি, is passing through polaroids, two polaroids, then first polaroid makes it to a polarized light, and the second one is the analyzer which is responsible for the intensity to be zero, or in other words, which is responsible for no light emerging from the second one. Here is the case, third polarizer is inserted in between these two, where the third polaroid is inserted in such a direction which makes theta with the first polaroid. প্রথম পোলারয়েডের সাথে থার্ড পোলারয়েডটা থিটা কোণ করেছে, তাহলে পরে বলছে ওই যে সেকেন্ড পোলারয়েড অর্থাৎ লাস্ট পোলারয়েডটা হয়ে গেল সেকেন্ড পোলারয়েডটা। সো আফটার লাস্ট পোলারয়েড হোয়াট উইল বি দ্য intensity of light? Because we know this polarization axis is nothing but the optic axis of a polaroid. Here is the when the light, unpolarized light is changed to polarized light by first polaroid, then its intensity becomes half. Why half? At the unpolarized light, there is a mixture of two types of rays. One is ordinary rays, another one is extraordinary rays. For first polaroid, the extraordinary rays are cut out, so the intensity becomes I0 by 2. So for the third one, which is inclined by Malus Law, we get I equals to I0 cos square theta, where theta is the polarization angle and I0 is the initial intensity. So for the third polaroid, which is inserted in between the two, in between the first and second, for third polaroid, intensity I equals to I0 by 2, and this polaroid is inclined to the second one or last one in the angle 90 minus theta. Why? Because the first and second is inclined to 90 degree. So the third one, when inclined to theta, so this one will be inclined to 90 minus theta. So after crossing this polaroid, suppose the intensity equals to I3, which is equals to, here is intensity for third polaroid, this is I0 by 2. So after crossing this, we get I double dash equals to I0 by 2 into cos square theta. It is I double dash, and here is I0 by 2. It is I0 by 2, the intensity, and after crossing, it is I double dash, which is equals to this. After crossing this, I3 equals to I double dash cos square 90 minus theta. We get cos square 90 minus theta equals to sin square theta equals to I0 by 8 into 4. Cos square theta sin square theta equals to I0 by 8 2 sin theta cos theta whole square. We know sin 2 theta equals to 2 sin theta cos theta at 12 standard. So this is I0 by 8 sin square 2 theta. So answer equals to A. In Young's double slit experiment, the intensity at a point P on the screen is half the maximum intensity in the interference pattern. If the wavelength of light used is lambda and d is the distance between the slits, the angular separation between P and the central bright fringe, we have to find this one. So first we draw the pattern, double slit pattern in this way. Here is the point source of light and his lens which coincides the rays into S1, S2 as two coherent sources of light. Mind it, this is a lens which makes the point source of light between two coherent sources of light. What are coherent sources of light? It will be discussed later after solving the problem. So here light comes here. After interference, this is D, suppose this is D and this is A, this is X. After interference, here at P, we have to find the relation which one is right. But we know I equals to I0, the cos square delta by 2, where delta equals to phase difference. At point P, So, according to problem I equals to I0 by 2, this is the standing equation for intensity of light for double slit experiment. So I equal to I0 cos square delta by 2 equals to I0 cos square delta by 2. By simplification we get cos delta by 2 equals to 1 by root 2 equals to cos of pi by 4, implies delta by 2 equals to pi by 4, implies delta equals to pi by 2. And we know twice pi by lambda into path difference equals to pi by 2. So twice pi by lambda into path, what is the path difference? Dx upon d. Here d is the separation between two slits. Capital D is the x is the dx upon d, because this is path difference. If we draw perpendicular, we get path difference as S2p minus S1p, which is equals to this length, because suppose this length is theta. Suppose this length is theta, so this length also is theta. So we get this angle because this angle, this and this line are perpendicular to this and this line. So angle between this is theta. So this is path difference which is equal to d sin theta. D sin theta is the path difference. And this will be equals to dx upon d because sin theta equals to perpendicular by hypotenuse because this hypotenuse is taken as capital D because this one is very, very large with respect to this length. So we get this is equals to pi by 2 implies pi cancel out 4 dx equals to lambda d or dx by d equals to 4 dx equals to lambda d. So lambda upon 4d lambda upon 4d equals to x by d. Now x by d equals to here x by d equals to sin theta. So sin theta equals to lambda by 4d. So theta equals to sin inverse lambda by 4d. So answer is D. Coherent source of light to such light whose amplitude may be same or a slight difference, but the frequency must be same. Also, their phase difference relation must be constant. In this case, S is the point source here. By focusing at convex lens, we get S1 S2 as coherent sources of light. You must know two same source but different cannot be a coherent sources of light. You also must know 2 points of a source, of a point source, 2 points of a large source cannot be a coherent sources of light. So answer D. The refractive angle and the Brewster's angle of a prism are 60 degree and 30 degree respectively. The minimum deviation is this. So there is the idea, we should have idea what is refractive angle, which is the vertex angle of a prism is known as a refractive angle. And what is Brewster's angle? The angle at which a light, if incident, at a crystal, then it will be splitted into plane polarized light and unpolarized light into 90 degree to each other. Then that angle is called Brewster's angle. Here to answer the question we have mu equals to tan I equals to tan of 30 degree and A equals to 60 degrees. So we know mu equals to sine of A plus delta m upon 2, this divided by sine by 2. Where from where this relation comes, we know for minimum deviation, delta equals to, we know delta equals to I1 plus I2 minus A. For minimum deviation, we should have I1 equals to I2. So delta equals to twice I1 minus A, and mu equals to sine of I1 upon sine of R1 equals to sine of I2 upon sine of R2. So from which we get delta m equals to, so I equals to A plus delta m upon 2, and we know R equals to R1 plus R2 equals to R1 on R2, so twice R A equals to this, so R equals to A by 2. So mu equals to at first edge, at first surface, this is A, at first surface when light goes into this direction. So this is, this angle is I, we get, and this angle is R. So sine I upon sine R. So we get mu equals to sine of A plus delta m by 2, this divided by sine of A by 2. Here this is not to be used here because this will take some time. We have to answer to the problem which is of preliminary level and of 1 mark and of 1 and 2 and 3 minute duration. So we get here 1 by root 3 equals to sine of 60 plus delta m by 2, this divided by sine of 30 degree. Sine of delta m plus 60 by 2 equals to 1 by root 3 because sine 30 equals to half. So half into this 1 root 3. So sine delta m plus 60 upon 2 equals to sine inverse 1 by 2 root 3 implies delta m by 2 equals to sine inverse 1 by 2 root 3 minus 30 degree. So delta m equals to 2 sine inverse 1 by 2 root 3 minus 60 degree. So this is the answer D. In Young's double slit experiment, lambda equals to 500 nanometer, small d equals to 1 millimeter, and capital D equals to this, the minimum distance from the central maximum at which the intensity is half the intensity, maximum intensity. So according to problem, we have I0 by 2 equals to I0 cos square delta by 2 because we have I equals to I0 cos square delta by 2. This is a standing equation for intensity at a point P. So according to problem, I0 by 2 equal to this, from which we get cos square delta by 2 equals to half. So cos delta by 2 equals to 1 by root 2. This is cos of pi by 4. So delta by 2 equals to pi by 4, or delta equals to pi by 2. Now we can write twice pi by lambda into dx upon this is the path difference, equals to pi by 2. Pi cutting out, we can get x equals to nanometer. Nanometer means 10 to the power minus 9 meter into d equals to 4. This divided by 4 into small to 1 millimeter, 10 to the power minus 3. This cutting out, we get 5 into 10 to the power minus 7 plus 3 equals to 5 into 10 to the power minus 4. So answer A. The ratio of intensities of consecutive maxima in the diffraction pattern due to a single slit. Given 4 options given here. We know I equals to I0 sin square alpha upon alpha square, where alpha equals to pi by lambda A sin theta. What is A? A is the suppose this is single slit. This is P point, is central maximum, and this is angle theta, and this is D, and this is X. So from this end and from this end, there is this type of diffraction, where path difference is this. Here, this is the intensity. So for central maximum, we get I equals to I0, because here theta equals 0 degree. For this point, theta equals 0 degree. So we get alpha equals to 0, but sin square alpha upon alpha square is not 0, because it is 0 by 0 form, which is by L Hospital's rule, can be solved by differentiating numerator and denominator with respect to alpha. We get a limiting value of sin square alpha upon alpha square as 1, which is of limit problem. It is to be not discussed here, because the answer to be taken, which is I equal I0 into 1 equals to I0. It was said for the maximum in the diffraction pattern for first, secondary maximum, For first secondary maximum, we get A sin theta equals to path difference, which is equals to, we know, n plus half whole into lambda. But for here n equals to 1, we get 3 lambda by 2. A sin theta equals 3 lambda by 2. For the first, so we get I equals to I0 into sine square 3 by 2 lambda. This divided by equals to I0 sine square 3 pi by 2. This divided by 3 pi by 2 whole square means 9 pi square by 4. So this is equals to I0 sine square pi minus pi by 2 upon 9 pi square by 4 equals to I0 sine square pi by 2 upon 9 pi square by 4, because we know sine of pi minus theta equals to sine theta. So this is equals to I0 into 4 by 9 pi square. For secondary maximum, we get A sin theta equals to n plus half n on 2 here, so 5 lambda so we get I equals to I0 sine square so the ratio will be I0 is to I0 4 by 9 pi square is to I0 sine of 2 pi plus theta sine A cos B plus cos A sine B equals to 1 sine of 2 pi plus theta sine A cos B plus cos A sine B equals to this equal to 0, this equal to 1, this equal to this is pi by 2 so this is equal to 1. So we get I0 into 4 by 25 pi square into 4 by 25 pi square. equals to 1 is to, so answer C. I0 is cutting out, we get 1 is to 4 by 9 pi square is to 4 by 25 pi square. Here this relation for the central maximum. For the maximum, we get A sin theta equals to n lambda. And for central maximum, which are called minimas, and for central maximum, these are called minimum, first minimum, second minimum. For that, n plus half into lambda by 2. So answer C. Number 9 problem in Young's double slit experiment. One of the slit is wider than the other, so that the amplitude of light from one slit is double of that from other slit. If Im be the maximum intensity, the resultant intensity I, when they interfere at phase difference phi, is given by this. So this is a problem of Young's double slit experiment, where two slits present, এই দুটো স্লিটের অ্যামপ্লিটিউড বিস্তার, এই স্লিট দুটো দিয়ে suppose this is the picture. So we know here I1, suppose the intensity from the first slit, we get I1 at T, a point which is at a distance x from here. This is the distance small d, but no till now. So here we get as I1 varies as a square, because intensity varies amplitude square. And also here is the problem says that the second one is of double amplitude from the first one. So this is I2 varies as 4a square, implies I1 equals to k times a square, implies I2 equals to k times 4k a square, implies I2 equals to 4I1. Now intensity at P can be given as I equals to I1 plus I2 plus twice root over I1 I2 into cos of phi. How it comes? We know resultant amplitude at point P equals to A1 square plus A2 square plus twice A1 A2 cos delta, here cos phi. It was said earlier that where needed, the problems are will be discussed at that point. Where needed, it will be analyzed at that point. সেখানে বিশ্লেষণ করা হবে যেখানে প্রয়োজন আছে। এখানে a square equal this we know, and here a1 square plus a2 equals to twice a1 তার whole square plus twice a1 into a2 equals to twice a1 cos phi equals to a1 square plus 4 a1 square plus 4 a1 square cos phi. So both sides, multiplying k by both sides, we get k1 square plus k 4k a1 square plus 4k a1 square cos phi. So I equals to I1 plus 4 I1 plus 4 2 into root over k a1 root over k 4k a1 into cos phi. K, what comes from here? 4k k1 k1 k a1 4k root k a1. So we get root k a1 into 2 root k a1 2 root k a1 4k a1 square. So we can write as I1 plus 4I1 plus 2 I1 into 2 I1 I2 cos phi. What is obtained here? So Im equals to I1 plus 4I1 because I2 equals to 4I1 plus 2I1 into 4I1. This to be 1 for maximum because we know minus 1 less than equal to cos phi less than equal to plus 1. So cos phi maximum is also 1. So we get this equals to 5I1 plus 4I1 equals to 9I1 implies I1 equals to Im by 9. Now I equals to I1 plus 4I1 plus 4I1 cos phi equals to 5I1 plus 4I1 cos phi equals to I1 common 5 plus 4 cos phi equals to Im from here Im by 9 4 plus 4 cos phi plus 1 equals to Im by 9 1 plus 4 1 plus cos phi equals to Im by 9 1 plus 4 into 2 cos square phi by 2. So after all, I equals to Im by 9, 1 plus 8 cos square 5 by 2. So this is the answer C. In identical waves, each of intensity I0 interfere each other. The ratio of maximum intensities if interference is coherent, and number 2 incoherent. We have to find the ratio of maximum intensities. We know Imax, if Imax is the ratio, if Imax is the maximum intensity for coherent sources of light, then Imax equal to, we know, root over I0 plus dot dot n times whole square. And why this comes, we know, for Young's double slit experiment, I equals to I1 plus I2 plus 2 root over I1, I2, Imax. Imax equal to, what does it mean? It means I1 plus root over I1 plus I2 the whole square. If for 2, for n times, this will be this. And for incoherent source, we get that just the addition of the waves. So I0 plus I0 plus dot dot n times equal to n I0. Here it is equals to n root over I0 whole square equals to n square I0. So I max upon I dash max equals to n. So answer will be A. So answer A. So this is all about our today's class. You may subscribe my channel Bidyut, and we shall meet you again. Thank you.